This is a cover video for Square Enix. I already did the job stuff in the application, so I'm just going to show off some of my personal projects. Here we have my website, where I just am hosting a couple of projects. I think I've only got one fully uploaded. Helioband is just a board game. It's cool, but is not applicable. Another tennis game, completely standard tennis game. It's just got 4 different characters that all act a little bit differently. It's played like a completely standard, regular old tennis game. It's not a timing-based one. You just get in the position, change into your hit mode, and you wait for the ball to come to you. So it's a game about like strategy and positioning. And we've got Ray Marcher, which isn't live on the website yet. The Ray Marcher I wrote from scratch, including math libraries like Vector3, Quaternion, Transform. Vector 3 and Transform weren't too difficult, just like a lot of debugging as they were getting built. Quaternion was terrible. Like, it's not a huge class, it's only 47 lines, but you've got stuff like this, which was terrible to type out. All of these are one-letter variables, and you can't make them longer and more descriptive, because it's just X, Y, Z, and W, and then A and B, you know, Quaternion A and Quaternion B, and you're multiplying A and B together in various ways. And I think it's like a majority of the combinations you could do in this line of code here. Sphere, easy. I mean, it's literally just a distance function, which is the same as the vector 3 distance function, but minus the radius. Camera is just linear algebra, tons of it. Multiplication kind of thing to stretch the camera out and rotate it into the correct direction. Then you're like setting up a bunch of rays in slightly different directions to give a illusion of depth. I'm just gonna run it here. So in this scene, the blue sphere represents the z-axis, which is forward. The green represents up, y, and red is off to the side. You can't see it right now. And it was representing positive x. And all 3 of those have their positions multiplied by a little bit around the positive x. So they're rotating, like rolling. If they were a wheel, they'd be rolling forward. So I'm just gonna expand it big and let the whole thing render out. I wrote it in Java and did everything from scratch, so I did not have access to the GPU. Reflections are calculated 4 layers deep, which is plenty enough to be smaller than the pixels on this device. That's about all it does. I was going to like add a world, and the mesh was going to be just lay out an area for the player to walk around on, but the screen updates way too slow. Yeah, you can see that. It updates way too slowly to be of any use if you want to do inputs. It's not fun. Not even. Nope. Run another tennis game, show that off for a quick second. See how long I can keep the ball going on my own, because I don't have anybody else here to play it with. So, let's put them right here. You enter a hit mode, and then the left stick changes from running to regular hit on A. You can see the cursor ends up on the other side where the ball is approximately going to land. A curve on X. I wasn't able to calculate a position for the ball on curve. And lob is on Y. So I'm just going to lob the ball straight back there. Ta-da! It was mostly for me to check out how Unity's triggers worked. These rectangles in front of the characters have a 3D trigger in front of them, and whenever the ball enters it, it checks if the player's in a hit mode, and if it is, it'll play the animation and send the ball in the other direction. Which is why I tell people it's not about timing, you have to do it in advance. Which is something that I would like to change, but I'm kind of done with this project. I gotta move on. I got bigger, better things to work on, the big old RPG, like Dokapon Kingdom. I want to make something like that. Thank you for checking on my projects, and have a good evening.